Okay, let's take a quick look at this. I do not really want or need to spend a great deal of time on this. Ladies, let me get you to turn around and face front, please. Take a quick look. Move those desks around. Put phones away, etc., etc. Thank you. Okay, so what this is about, these are really lightweight versions. I'm going to give you some more challenging problems to do. But you can use, I would encourage you to use matrices to solve these linear systems. So what I want to do is this is a big topic also. This is one that, a lot of big tests, SATs, ACTs, Compass, etc., expect you to be able to handle word problems that essentially equate to solving a linear system. Okay, so let's just very briefly talk about some strategies, and then it's just a matter of doing them, getting used to them. So, what about this one now? Plan to work 200 hours this summer, mowing lawns and babysitting. You need to make a total of $1,300. Babysitting pays $6 per hour, and mowing pays $8 per hour. How many hours should you work at each job? Okay, I want you to just take a second here and think about this, about how you could approach setting up a problem like this. In fact, take 30 seconds or a minute at your tables and just, turn to your neighbor, and in groups of 2 or 3 at your table, so you guys pair up. Talk about how you could begin to approach a problem like this. Because our goal is we want to come up with kind of a strategy. And then once we get a strategy, we should be able to apply it in virtually every case. What would you do here?
Do you have to do both, or could you do one?
What do you mean?
Well, could you just do mowing instead of babysitting?
Oh, it might be that you decide to do one or the other, sure. You can do whatever the math tells you you should do.
Are we trying to make exactly 1,300?
You got to make exactly 1,300. So not more. Yeah, it's kind of a weird question, but you're trying to figure out what combination would give you exactly 1,300, not which one's going to give you the most money.
So we have an extra $300.
Maybe, yeah.
No, we do.
You figured it out, yeah.
God, those $300 extra, that would just be horrible to have that. I wouldn't want it.
And you're $100 short because you just do basic.
Aha. So somewhere in the middle is the right combination.
So you gain 2 for every mowing you do instead of that. So
That's one way to do it.
So you need to just do 50. You can do do 150.
Okay, and while you're talking about this, I'm gonna kind of give you a little bit of information that, think about this in terms of this is a really small trial 2x2 system.
I got it.
But I'm gonna give you some, I think I'm gonna give you almost exclusively 3x3 systems to solve on the homework. And so even though you may be able to power through this one, looking at patterns and numerically, once again, you want to come up with a strategy that you could use even for much harder systems. How can you turn this word problem into a...
I have the answer, but yeah.
Okay, well I'm not, okay, and the answer is important, but I'm more concerned about the technique or the method or the strategy than the actual answer here.
What if there really isn't a strategy?
No, there is kind of a strategy. I mean, it's not like there's just a step 1, do this, step 2, do this. But there is an approach to doing word problems in general, and specifically linear system word problems. And this is something we don't probably do enough of in our schools. Okay, anybody have any ideas? Let's kind of come together here and we can put our thoughts together and see what we got. Yes, ma'am. Ideas? Yeah.
If you do 6x plus 8y equals 1,300, how
Okay, good.
And then we do x plus y equals 200 with the number of hours.
Okay, good, good. Now that's the system. But how do we get there? So how do we know? Now, in what you said there's some really good things. I heard x plus y equals 200, 6x plus 8y equals 1300. What are the x and the y?
The hours is only an hour.
Oh, okay, good, good. Now, what about this, the way this question is asked up here might indicate right from the beginning that those ought to be our variables. And if you call them x or y, or you could call them B and M for babysitting and mowing, or doesn't matter what you call them, but whatever you decide to call the variables, what do you think? Cammy's got an idea. What tells you that those might be the variables? Bingo. Because the question typically asks what the variables are, right? It wants to know what the values of the variables are. And so one thing that's useful to do whenever you're doing word problems is you always want to go to the question or questions and try to identify, what is it here that's being asked? It wants to know how many hours, wants to know how many hours should you work at each job, right? And so there's really two questions being asked there. How many hours are you going to mow? How many hours are you going to babysit, right? Okay, so those are our variables. So maybe the first thing we want to do then, oops, that's not really what I wanted, is it? There we go, how about this? So they called it M. I would personally use just probably X and Y, but you know why they use M for mowing, so you can keep track. B for hours babysitting, so those are our variables, right? And then what we want to try to do is come up with two equations that relate to two pieces of information relating to those. Now, typically, this is kind of a cool thing too. Typically, each equation is going to correspond to a particular concept that involves these two, or a particular usage of these two variables, right? In this case, we've got two ideas floating around in this question that are given to us in the background information. One of them is the total amount of hours you work, right? So the total amount of hours, they give us that information, that must equate to some relationship between these variables. Well, it does, right? If the total number of hours is 200, then how do we use M and B? M plus B is 200, right? There's one equation that comes from that idea, that piece of information we're given, the 200 hours. Now, what's typically useful is to look for the numbers, right? Look for the numbers in the background information, and the numbers are going to be related to the equations that we use to build our system, right? So B plus M is 200. Now, what about the other one?
M times 6 plus, no.
Think other way.
B plus 6.
B times 6
Yeah, B
equals...
times 6 plus M times 8
Good,
equals...
okay. And usually we put those coefficients out front, right? So we'd say something like this. 6B plus 8M equals 1,300, because now the other number we're given is this $1,300, is what we want to make, right? So if we want to figure out how much money we're going to make total, we need to break that down into the amount we're making from babysitting, which would be 6B, plus the amount we're making from mowing lawns, which would be 8M, right? That gives us our system of two equations. Once we get the system, we can sort of shift into algebra mode and forget about the word problem and just solve the system, right? Once we get the answers, we have to kind of come out of algebra mode and go back into word problem mode and say, okay, now how do we interpret these? How do we, in this case, when we solve this, and they use substitution, but we'll probably use matrices because you're going to have bigger systems that you're going to be doing. Regardless of how you do it, we're going to get some answers out of this. And let's just skip ahead to the answers. Well, we got M is 50 hours. We got B is 150 hours. Really what we got is M is 50 and B is 150. Then we got to come out of algebra mode and go back to the problem and say, okay, now what did those mean again? M was the number of hours mowing, so there must be 50 hours mowing if the numerical value of M is 50, right? We said B was the number of hours babysitting, so therefore we know we're babysitting for 150 hours based on the context of the problem. right? We take our math solution and apply it to the actual problem. Okay, let's try another one. See if we can just quickly come up with the equations here. Okay. So what do you think? What are our variables here?
Small wreaths and large wreaths.
Yeah, look at the question. How many of each size should you make? So number of large wreaths, number of small wreaths, right? So those are our variables. Whoops, I guess they don't list the variables. So what would the equations be then? Well, there's one of them.
And the other one would be L, or 12 times L, and then 8 times S equals 400.
That makes sense? So the number, and this is pretty typical. A lot of times when you're working with a system, one of the constraints or the ideas, and usually this is really a constraint, isn't it? Because it limits the amount of each we could have. One of the constraints is going to be that just how many do you have total? That's very typical. And then the other one, a lot of times is a cost or it's some kind of a weighted amount. In this case, the large wreaths are weighted more strongly than the small wreaths if we're talking about price because they're $12 a piece and these are $8 a piece, right? It might not always be price. It might be, it might be something different. It might literally be the weight, like maybe the mass of one object the density is different than the density of the other object, and you could use the densities to find the total mass or something like that, but it's the same concept, right? And then we would just solve that to find our answers. And in this case, works out that 20 small wreaths and 20 large wreaths fits perfectly here. So there'll be 40 total, and they'll make $400. Okay? Last one. Okay, this is a little trickier maybe, huh? See if you can, okay. What are obviously the variables going to be?
Would be grapefruit.
Grapefruits and oranges, so O and G, I guess. Now, what are some equations? See if we come up, nobody say it out loud, but see if your group, if you can come up with your table, come up with the two equations. So none of these equations are just simply numbers, are they? They don't tell us, we have no constraint on the number of each that we could have. It's all based on weight and cost.
Plus 0.75 times. What we'll do each one for each. So you got O times 0.5 plus G times equals 13.
Okay, let's see here. Can a table tell me what's going to be the equation that has to do with the weight constraint? So what's the equation that comes from the information about the weight? What do you think? Table. How about this table back here? You guys got an answer? You got one up here? Okay, you guys take the first one.
It's 0.5 times O plus 0.75 times G equals 13.25.
Okay, does that make sense? Does that make sense? We're told that the boxes, the gift boxes, whatever these things are, need to be 13.25 pounds per gift box, right? So that's a constraint. We know the average weight of each orange and each grapefruit, right? And so we ought to be able to set up an equation that way, right? The total weight of all the oranges, if each one is 0.5 pounds, and O is the variable representing the number of oranges, then doesn't it make sense that 0.5 times O represents the total weight of all the oranges, right? So we get something like that, don't we? 0.50 plus 0.75 G equals 13.25 total, right? What about the price one? If we want each gift box to have a retail value of $21. Sure. So the oranges are 75 cents a piece, they have a retail value of 75 cents a piece. Grapefruit, $1.25 a piece. So 0.750 plus 1.25 G equals 21 then, does that make sense? There's our system, go to town, right? Okay, so I'm gonna give you bigger ones. They're gonna be a little tougher, but that's what we're looking at. This is the last assignment, then I'll put the review up and we'll take the test here soon, okay? Sound good? Okay, 205, off we go.